Finance with R. Our presenter this afternoon is Ronald Hochreiter. Ronald is professor at WU Vienna University of Economics and Business. Ronald's also presenting, or co-presenting I should say, a workshop along with Patrick Burns and Michael Sun entitled Finance with R, which is going to be in London on the 6th to 7th of November. Also, just to mention that this webinar is also available as a recording afterwards. So Ronald, I'll hand over to you.
Okay, thank you very much. So hi and welcome everybody. It's still 8 in the morning here in the West Coast in Los Angeles, so I'm still, my voice is probably a bit broken. I apologize for that, but let's start with Finance with R. So in this hour, what we'll try to do, I mean, I don't know how familiar you are with R, but if you are not really familiar, or however, how familiar you are, I will start to love the simplicity of R and its extensions. And because what we do, we will solve financial engineering problems and really complex problems with real ease. And after all, some people still don't know that large investment banks and also the large hedge funds already use R extensively to solve their problems. I mean, we only have 1 hour, so we have to be quick, and the area of finance is pretty huge. So there are many sub-areas we could focus on. I will probably focus on portfolio optimization in some sense, because it's so important and it's the basic ingredient of what we really can use. So Alec already told you that if you really like what you see and you want to get a real hands-on experience, then you should really check out this workshop in London, where we really will teach you how to do that hands-on. I will just show you some possibilities, and you will also get all the codes that I'll present today on the homepage, which is quite new, which I just created to support this webinar and also the workshop and the following workshops. You can register to the members area for free using the following code. It's just webinar 3289. So I'll get to that back later. So just in case you don't know, R is more or less a high-level programming language which was designed to do statistical computing and graphics. And even its self-description is very just an understatement. You can find everything about it here, because in reality everyone is currently sure that R is the best tool for any business analytic tasks, including all the financial engineering problems. And on top of it, it's free and open source. And there's another thing which is really very useful, and also we will use today, is there's also a free and open source IDE for R, which is very nice, because some people complain about the GUI of R. So if you use RStudio, which is also free and open source, we will use it, you will see it, and it's available for all platforms, then just use that. There's also one, I mean, there are hundreds or probably thousands of resources on R, but one of these I really recommend is that one called Quick R. It's at statmethods.net, and it's really helpful, especially if you're learning and also if you're using R. But again, as time's running fast, let's just dive in. I'll just see someone raised the question. So how do I handle it? But let's dive in. As I said, I don't want to present slides, but to dive in directly into the RStudio GUI. So what we see here is everything we need. In the left upper corner, we see the code, which you will also get afterwards by registering by email. You can always request it. It's all the commands we will type and use to do what we're going to do today. So one of the major things on R is that it has a very good core, which focuses on all the mathematics and statistics functions. But then there is the specialty is that there are hundreds of people who provide packages. So for each and every application area, you probably find some package, some extension for R which you can use. For example, the first package we'll already use is called F-Portfolio. As you can tell, it's a main package for portfolio optimization. So if we just use R, in the left down-hand corner, you see this is the R front end. This is the R command line interface. So, for example, if we want to use a library, we just tell R to load this library. Now, once we said we want to use the library, we can do. And important is we do not only have functions, but in some sense, for example, the F-Portfolio library also provides data sets. For example, as we want to do portfolio optimization, we will start with some data. And the package F-Portfolio provides, for example, sectorial data, return data from the Standard & Poor's indices. So if we just load one package and issue one more line, we already got provided data of the most important Standard & Poor's indices for basic goods, industrial goods, and everything to telecom, utilities, financial, and tech. You see the return series from the beginning of 2008 until the end of October 2008. Okay, we'll just start with that, but what we also see here is that what's are really good at is working with data sets. So, for example, once we have a data set, we can check it out with, we can check out its head to see which part it has, and of course the tail of the data, which is very common, which is very useful to work with large data sets. I have to say, if you're a MATLAB user, the handling of data is a bit different. So if you're just in this world of working with matrices, you just have to think a bit differently. You will get to that, because what we see here is not a matrix, it's more or less a data frame. And also the vectors are some kind of lists, and you just have to keep in mind that it's a bit different than working with matrices in MATLAB. But at first, let's say, just by loading a library, we already have data which we can use to work with. So just load the next library, which is called Performance Analytics. And when we do that, what we get is what R really good at is doing graphics. So for example, now we already loaded two libraries. The first one got us some data which we can readily use to test, for example, portfolio optimization techniques. And then what's next is, what's also good is we have good functions to use, for example, time series data. So sometimes if you take a look at MATLAB users, what they do is they really have to create own functions to do all this dirty time series data stuff, which can be pretty messy. When you use R, you really have functions for that. For example, there's this command window, which really means select a time window. In this case, we just, from our Standard & Poor's sectors, what we want to do, we want to get all the data from 2006. So when we got that, in the right upper corner, you see now we have a time series object, data 2006, which is a subset of our data set we have seen before. So the second package we used provides us beautiful graphics. So for example, there's just one command and we get the performance graphs of the SPA Standard & Poor's sectors in 2006. So, I mean, this is really perfect. I mean, in the end, what you see, you need to type 4 lines and you have a perfect, good-looking graphical representation of the data. And of course, you could go on for hours just to see how to configure these graphics, but most packages already provide quite a lot of ways to focus it. For example, there's this special color set which is called red focus. I'll just show that on the first 6 rates. So, for example, this is just the same chart. You see the cumulative return, you see the daily returns, the bar chart, and you see the drawdown. And for example, this color set is quite important if you want to highlight one asset out of it. So you see, the packages provide everything. They provide you with the commands you can use to make beautiful graphics. Of course, this color set is not really useful to prepare reports if you're not just focused on one asset. So in this case, you just use another mistake, another color set. And the thing is, what are you going to do with R is doing automatic reports. So in the end, what you do is you create an R script which then automatically creates some executive or technical report using the latest data. So without just showing the graphs, what you can do, you can also just write it out to files. The R syntax, and that's what will be discussed in the workshop, is, I mean, it takes some time to get into it. Yeah? For example, if you don't want to output a graphic to the screen, you just have to, the first part is clear. You say, okay, I want to create a PDF with that name. Then you then you apply all the graph commands you want to apply. Then you say def off, and then this file will be written. We'll get to that. We'll get back to that later. But now, after seeing the first graphic functions, which are really, if you think about it, really tremendous, because they're readily available, and there are many of them. Just showing you just one little example of the graphics, which is the performance summary. But now let's do something more. We'll first start with the simple portfolio optimization. So there's another package we will use, which is called time series. But interestingly, the package time series provides a simple portfolio optimization. Remember, the data we are using is still these sectorial data from Standard & Poor's. Now, for the portfolio optimization, we use the whole data set, so from 2000 to 2008. So we just say, okay, give us the result. They want a result of the portfolio optimization of data. The point is that every package provides lots and lots of new functions which are well documented. And so, for example, there's also in R you have a command which is just the question mark. So, for example, we can say question mark portfolio optim. So now we see what portfolio optimization this command does. In what it does, we compute an efficient portfolio from the given return series in the mean variance sense. So what we really do with this command is we do a complete Markowitz style mean risk optimization, just one command, and we can see in the subset portfolio weights, we do have the portfolio weights, so we just make a bar plot out of it. And we see we have these 11 assets, and these are our asset weights. And once again, this is what we will discuss in detail also in the workshop, and you can find it in the resources I've shown. R is very flexible in creating graphs. So this, what I show here, is just the basic modification. Like, okay, now we add the assets, the asset names to it, so we see, okay, so we can do what you can see what the optimal portfolio is all about. Of course, there are lots of options how to customize the graphics. For example, I just changed the color of the graphs, but of course, there's also more. There are more complex things. So, for example, what I do here, you see in line 43 to 45, more complex things. If you, for example, want to add the portfolio weights on top of the bars. So this is what I do now. You see, now we have the portfolio weights are written on top of the bars. Of course, these commands look a bit difficult, but once you get used to the syntax, you really love it. So this is our optimal portfolio. We can see it in the graph. And now the next thing is, for example, we really have every graphic available. The basic pie chart looks like that. Of course, there are some glitches. In this case, these are the assets where nothing is invested. So we can get around this doing this. But for example, if you say, okay, I don't really like the look of this pie chart. What I really need is a more fancy pie chart. For example, a 3D pie chart. What you do, for example, is take a look. Probably there's even a library which makes beautiful 3D pie charts. So in this case, for example, there is a library that's called Plotrix. Also, every library is available for free, and you just install it and then you can use it. And then you have just the same command, which is just extended by Py 3D. And when you run this, you get a beautiful 3D pie chart of your portfolio. But even if you don't like the looks of this pie chart, I'm pretty sure that you will find some package which provides some even more beautiful ways to plot your results. This is the main thing about R, is that in what you have seen, I mean, we just by issuing a few commands, we already did what you would. We already did a lot, like portfolio optimization, plotting that, and this is just because everything is available in libraries, already readily available, free libraries. So, but of course, this is just a very basic portfolio optimization. As we did before, we already loaded the library F portfolio because it's the one of the major portfolio optimization library. And we want to use that for portfolio optimization. When you do this, you will immediately figure how easy it is by just issuing some commands to do something which would take you ages with any other software. Let's say, okay, we want to use the data from beforehand, so the Standard & Poor's sectorial indices, and we want to build a long-only portfolio. We will get back to the constraints afterwards. So while we just created one portfolio, what we really want to do is we want to build an efficient frontier. So we want to build an efficient frontier with 25 points on the efficient frontier, and of course it's a quadratic optimization problem. So we also select the solver here. We'll get back to, I mean, the details. It's not that important, but again, what we did so far, we just loaded a library. We said the computer, yeah, do just the long-only constraints, 25 points on the efficient frontier. And now, when we check the portfolio constraints, already you see we get a complete description of our constraints and basic information about the assets. Then we just issue one more command, which is already the calculation of the efficient frontier, and we can take a look at it. What we can see here, we have the 25 optimal portfolios on the efficient frontier. We can see he shows us the current print command shows us 5 out of 24 portfolios on the efficient frontier. We can see 5 of them. It's just a long only, and we'll minimize the risk. So classically Markowitz mean risk optimization. And then you see it was just more or less 3 commands so far, and then every package really provides also beautiful visualization functions. So if we want to plot the efficient frontier, we get this very beautiful picture down in the lower right, what you can see. about the portfolio optimization. So we can see all the 25 points in our efficient frontier. We see the assets all in the risk, in the mean risk area. So there you can see the power of it. So without issuing too many things, without doing coding, we can do portfolio optimization with ease. For example, there's then another plotting command which is called weights plot, so we can see the weights of the portfolios given the different, wait a moment, sorry about that. We can see the different asset allocations for different target returns. So this is exactly the 25 portfolios we wanted to calculate on the efficient frontier. Of course, once again, if you don't like blue color, or if we want to have, if we have to specify a color scheme matching our company, then we just use a different color set, or for example, we use the thing. So for example, this is another color set, or I'm sorry, I'm sorry to be interrupted. You have different color sets, so you can really customize these plots to your, for example, corporate identity. Once again, let's get back to the constraints. Now, there's also the power to really specify everything. So for now, we just have a long-only portfolio, but let's say as a first extension, we just want to add a constraint, which is having a maximum of 0.5 in a maximum investment in our assets. So we just issue that we don't want a long-only portfolio, but we want to have a maximum investment for all the assets. In no asset there should be more than 50%. So we just take a look again at the constraints, and we see the upper level of investment has been set to 0.5 for all the assets. So we just do the optimization again, which is pretty quick, as you see. And now we have the addition that there are constraints, so it's not just a standard long only, and we can plot the efficient frontier again, which looks different now, of course, and especially if we take a look at the weights plot, we see the maximum of 50% investment is really kept. It's even possible to to add more complex constraints, like for example, we want to the maximum investment into each asset is 50% of our budget, but for example, the minimal sum of investments into the telecom and the technology area should be 10%. So of course, and you can one after another of these constraints and specify to your problems. So there are really complex constraints which you can add. You can see what we see here. Now there is in the lower corner, you now see there's this lower limit of 10% in telecom and technology. So we just start do the portfolio optimization again. We of course get down a different frontier, and we can take a look once again at the weights, which are now where you can see we always have 10% into tech and technology and telecom and technology. So this is really a package which is heavily used around the world, because whenever you want to do Markowitz portfolio optimization, why should you really re-implement everything that's available if you can do it with that few commands? Of course, there's one thing. Up until now, we just used this predefined data set provided by some package. And of course, this is not interesting because we need to use our own data. So there's another package, as you could tell. Of course, it's all about packages, which is called QuantMod, which is also next to F-Portfolio, one of the packages you really rely on when you do financial engineering or quantitative finance using R. So we just load this package, and then there is a function which is called getSymbols. And we just have to type getSymbols, in this case of the ticker symbol, which most of you probably know, that's Apple. We just click getSymbols of a stock we are interested in, and this function getSymbols grabs the data from the internet, in this case from Yahoo Finance. So QuantMod, as opposed to the library above we used, uses different charting tools. For example, what they like to do is to resemble the Bloomberg terminal. So if we do chart series and you're familiar with Bloomberg, the Bloomberg terminal, then you can see, okay, this looks somewhat familiar. This is the with a black background, and we see the data of Apple. So what we also can see, it's from the beginning of 2007 until quite recent, until last Friday. So of course, every package which provides different charting options also provides other color teams. So for example, we can also check out the same graph with a white background. Of course, we also can, what this also does, we can also specify what we did not do so far, specify a time frame, which is also very important. For example, what I do want to do now is to load all the recent data of all the stocks that are in the Dow Jones Industrial Average. So for that, I prepared a vector with all the ticker symbols of the Dow Jones. And then what I do is I want to get the daily returns of all these indices from the 1st of October 2011 until quite recently. So we do that, and now we have to wait a minute because what's going to do now is all the data is being loaded from the internet. So what we see now, if we take a look at our data, we end up by having all the return data of all the 30 assets from the Dow Jones Industrial Average, which we have defined here in this area, in this array in line 107, and we can, for example, go on with that, because this is what if in the case of creating some financial report, which we really want to do, trying to get the data which we need. So this is the most recent data of all the stocks in the Dow Jones Industrial Average. Now we have what we have now is a matrix. And what's important for R is that we combine, that we convert sometimes standard matrices into special into special objects, like in this case, into the time series framework. So we do that, and we hand over the column names to the ticker symbols. And when we now take a look at this new time series data frame, then we can see, okay, we do now have named columns and time series framework. So once again, now we loaded the data that we really want to optimize, and we want to do a long-only portfolio once again. So we just, so the new thing is loading the data we really need for our analysis, and then repeating what we done before, taking a look at, for example, the portfolio constraints now with the new data. We see, okay, long only, so we have no restrictions between upper and lower investment, it's just long only. We get, again, a description of our data, and we just go on by calculating our efficient frontier. So we can take a look at it and once again plot it. Now we have, of course, quite a lot of assets, and we can see, of course, what we can, for example, see is that it was not really a good year for HP, Hewlett Packard, return-wise and risk-wise. So, but still, you see we have 30 assets, and we get a graph right out of the box of this library, which is really beautiful, and you can include in some report right away. Of course, there's also this weights plot where we can take a look at the investment of the portfolio given the different target return levels all around our portfolios, our frontier. So sometimes if you say, okay, maybe a portfolio optimization might be too much for me, I'm, for example, just interested in creating a first risk report. Of course, this is what we're going to do next. So, of course, it's very fancy to just use some commands and get a portfolio optimization, but let's tune down a bit and just create a standard risk report about the assets we just loaded above. So, for example, very often we need to create some Excel sheets, so which is also very convenient with R. So in this case, of course, the implementation is very basic so that you can see how to do it. What we want to do for all the assets we selected, we like to have the mean, the standard deviation, the value at risk at various levels, and the conditional value at risk, the expected shortfall, how you call it, tail value at risk, overall the assets of the Dow Jones Industrial Average with the return data of the last year. So once we do that, we just make a first loop, and for each of these assets we calculate its mean, its value at risk, so its quantile, or of course its conditional value at risk. So here you can see that all these statistical methods like calculating the mean, standard deviation, or the quantile, it's really something which is at the heart of R, because it started out as a classic statistics package, and it ended up as being the tool for business analytics because of all the packages that are provided. So once we do that, we really get now this first basic risk report. Of course, it's very basic just to see how to do that. And which is also important, we did some lists with all the risk parameters, with some, of course, very few risk parameters. You can extend it easily. But what we do again is doing a so-called data frame. So we enter all the data which is calculated. We combine them into one data frame. We name the columns of the risk report, and once we take a look at our risk report, we can see that's exactly what we see here. We have the statistical parameters of all the assets over the last year, with the different value risk, the different conditional value at risk. And we just write out this risk report, for example, in this case, to a file that's called riskreport.cvs. The next thing we will do is we also take a look at the correlation of the assets. So we will write a second file where we additionally use the ticker symbols to really have a beautiful, more or less beautiful risk report about the correlation. So we do that. So what we did now, we wrote two files which we can right away open with Excel. So taking a look at that, here we see the files that have just been written. As you can see, it's 8:33 in the morning here, but this was just written now, and this is the risk report we've just seen as a data frame in R. Now we have the report in Excel, and we can do whatever we want with it. We can beautify it, we can make Excel graphs if that is needed. Then, for example, we also wrote we wrote a second file, which was the risk report about the correlation. So we just load that and we see, wow, we now have all the correlations in Excel, and we can, for example, beautify or whatever, do whatever analysis we need in Excel. So more or less, if you would really use R in some for some setting, what you do is you create reports, you create Excel sheets, and do all the analysis in R. But it's really convenient to create reports, Excel sheets, whatsoever. So enough about that. We can see how easy it is to just write standard Excel risk reports now. So also, but when you think about doing standard statistics, which we started right here, calculating quantiles or whatever, as I told you, R started out being a pure statistics package, so it also provides perfect utilities to do standard statistics, like, for example, the regression. Take a look at the most boring statistics textbooks example of having the linear regression. So, of course, this is really too boring. I skip over it just to see we have some persons where we have which we measure, so height and weight. And then what you can see in the next line, 160, this is important. This is where we see how to do a linear regression. And it's just we have this special operator of the tilde. So when we do a linear model, linear regression model on Y, get the result immediately. So you can see, of course, with having this very neat syntax, we see that R is really into basic statistics. But of course, using this basic statistics, like above in the calculation of the value at risk, is also very can also be conveniently applied to the financial markets. Take a look at just testing the efficient market hypothesis. In this case, we'll check it out with the daily returns of the Microsoft stock in 2010. So what we see here, we just select our ticker symbol, we select our time frame, and then what we do, get the data. Here you see what I've done is you've seen simplified commands, but this is exactly the complete code which you would use to calculate the return series of this data. Once again, the function get symbols is from the library quantmod. Sorry. So here we get the Microsoft data from Yahoo Finance. In this specific time frame, get the prices, which is the let's browse through because it's important. If we take a look now at the data, what you can see is we get all the data that's provided when you used Yahoo Finance. You know that we get the open, the close value, we get the high, the low value, we get the traded volume, and the adjusted close. For our analysis and portfolio optimization whatsoever, of course, we just select the adjusted close price here and calculate the return out of that. So in our red, we do now have the returns, which we, for example, could take a look using a bar plot. So here you can see the daily returns of the Microsoft stock in 2010. So let's get back to the efficient, so this was the getting the data. Let's get back to the efficient market hypothesis. So what we want to do is checking the correlation more or less between RT and RT minus 1. So we generate these two lists of the returns, and we see, of course, there's a very low correlation. And now what's important, just to see how to also make this make use of the simplified statistics models, what we do now is exactly what we need to test the efficient market hypothesis, doing a linear regression of RT and R, get a summary, where we can also, whenever we use this this type of data, we can statistics methods. We also get lots of hardcore statistical outputs, like all the p-values we need. So once again, I just showed you what's really all about. But if you can, for each and every comment I show you, you could really go on for hours and check more detailed results and whatsoever. And of course, now we plot it and we see, okay, this is a familiar picture of seeing how the return of a time series relates to the return of the previous day. So this was the first overview of the methods here. So once again, what we did is seeing how quick we can use all the things, for example, in portfolio optimization case, how complicated it is in other tools, and how simple it is in R. The next thing we have seen is that it's very convenient to do graphs. I mean, I also showed the basic graphs in portfolio optimization sense, now a bit in statistics, in linear regression, and of course the beautiful graphs which you can do when using the finance libraries. And once again, what I also showed with the 3D pie chart is that if you don't, if the basic plot functions don't really fit your needs, you probably find some library that gives you a quick solution. And if it still doesn't help, there are many options to customize your graphs. So that was the first part of the presentation. I've seen there are some questions. Okay. Anyway, so after this first part of the presentation, I'm now probably up for discussion. So I'm happy to see your questions now in the question frame. I see some. Okay, I mean, there are some questions about specific applications in finance, and of course, you see, if you want, for example, if you need to apply all this data to CDS analysis, you can of course do, and especially all these volatility problems and volatility surface estimation. This is really just the first presentation of what is possible. If you browse into the possibilities of all these packages, this is what's really the power of R. So sometimes it's even more interesting to so it takes more time to figure out the correct package which solves your problem, because there are many of them. So, but I'm pretty sure you will find the package that helps you, because new packages are generated daily, and there's practically no problem that's not being handled with. So, are there any other questions? No? If not, what I can what I can also show you is, for example.
So Ronald, actually, there are a few questions. I'm not sure if you can see them all.
Okay, so
if you scroll down, I think, or if you undock the questions tab, you should be able to see some more.
Okay. Once again, the script will be, I will send all the scripts and everything, all the presentation to you if you enter your email at the homepage. So once I have that, I can send to you. So you just browse to finance-r.com. Then you can then you click on the register tab. Of course, it's free and everything, and you just enter this registration code, so I know where you're coming from and which thing to send to you, and then you'll get everything you need, so you can easily redo all these things. So this was, okay, wait, I have another question here. There's the question about if you can import your own data directly from Excel. And yes, you can do. So reading and writing Excel files is also possible. So what I did now, for example, even writing R files, I just wrote comma-separated value files. But as you can tell, there's, for example, a so-called library which is called XLSX. Okay, that wants to say, okay, it doesn't want to load it right now, but which is a perfect interface between Excel and R. There's also another tool which is only available on Windows, which makes sense, where you have other functions which are using directly the Microsoft interfaces, which is called RXL, the library, which can be used to import and export the data directly to Excel. So you don't have to mess around with any data conversions or whatsoever. So this is not a problem. As one of the ideas, for example, is you have one input Excel sheet and one output Excel sheet, and you just run the the R code in the background to do all these complicated calculations, and with, for example, new data from importing from a new Excel sheet, you create the Excel report more or less. Yeah, there's this question, of course, that I sincerely apologize for being very quick. It was just important, you know, this is the most basic subset of the functions that are available, and I just wanted to really get at least all the portfolio optimization and the generation of Excel sheets into this hour, because to see at least to get the glimpse of the real power of R. And so this is why Unicom will definitely make this video available for all of you, so you can check it out once again. And of course I will send you via email once you register at the homepage. I will send you all the scripts, so it will be very easy to really redo everything I've shown on your screen. So if you have, I can also offer, if you have any questions, quick questions, I'm also here to help. You can always send me an email. Next question is, for example, exactly about the question about Bloomberg interfacing. Yes, there's also an R package for interfacing Bloomberg, which is very convenient, of course, because if you serious financial data, not just those of stocks, then you need, of course, some computer with an Bloomberg access, and you use the R Bloomberg interface, and it's really easy and simple to do to get then, for example, futures data or intraday data, because R is pretty heavily used for intraday analysis too. And so the Bloomberg interface provides you all the data if you want to do, for example, intraday analysis, futures analysis, futures portfolio optimization. So my students, for example, use the Bloomberg interface quite heavily. There's the question of where's the best place to find packages. If you go to the R homepage, you'll find a list of, you find, of course, the list of packages, but there's also something which is called views. So what you can see here is on the R homepage is something that's called task views. So what you do here is you select the type of application area you're into. So for example, in our case, it's finance. So this task view gives you an overview of all financial models packages that are available. Just take a look at this page. This is the task view empirical finance. So it starts with standard regression models, where you can find, okay, if the standard linear model, which I've shown very quickly in the webinar, is not enough, you can use that. There are lots and lots of packages about time series analysis, which I skipped today completely. But these task views are very useful because the list of packages is too long, and so there you go to the task view, take a look exactly what you need, and you'll quickly, I assure you, quickly find your the package you really need. There's also a question about this is always the case when you talk about R. There is a question about the performance, and of course, if you really do data-heavy stuff, you need to use, you name it, packages. For example, if you take a look again at the current task view, there is a task view on high performance and parallel computing with R. Which is interesting. It's also, there's direct support for parallel computing in R, and there are, as you can see on this page, there are lots of parallel computing packages. So I can tell you that people use R with really crazily large data sets, and there, I'm pretty sure you will find a package that you can use to even crunch the largest data set you you can think about. So the performance probably was a problem, but it's not now. So I've also seen that some say they have problems with registering the email. If you have any problems with registering, please just send me an email. You'll just Google my name and you find my homepage, or you see it also on the main homepage, and just send me an email with your email address, and I will quickly reply to all of you who registered or sent me your emails with all the codes and the scripts and the slides I've shown today. So, are there any other questions which I probably could answer? Once again, you get all the codes, all the slides with the pointers to the pages, the crown view, the task view is quite an important thing to get started. What I also said is this quick R, which is really the most fantastic source if you want to start with R and just start by learning its data input, data management. You really get everything here, and it's also a free resource that you can use all the time. So all the pointers to these web pages are, of course, you can see it now in the recorded webcast, and of course it's also in the slides which you get in the email package. So, are there any other questions now? I'm still up for questions.
Oh, thank you, Ronald. That was excellent.
Okay.
Just to remind everybody that if you'd like to meet Ronald in person, he will be presenting in London at the Finance with R workshop on the 6th and 7th of November. So,
okay, so thanks everyone for listening. I really enjoyed it, and have a great day.
Thank you. Goodbye.
Goodbye.